All right, what's going on, Internet? So today we're going to talk about what nobody really talks about when it comes to RAG. So oftentimes when you look at RAG setups, they're deceivingly easy to set up, but they're actually kind of hard to master. And there are a million different ways you can improve your RAG setup for retrieving information in an effective way. Now, instead of looking at all 60 or 70 ways we can do this, what I want to do is I want to focus our attention on 80-20. So what are the 20% of the different tactics we can leverage to get 80% of the results to improve our RAG retrieval? So we're going to do things a little different today. I'm going to draw for you on my tablet instead of my computer so you can see my head, the top of my head a little bit more. And of course, we have our slides. So here we have a spectrum. And on the spectrum, we have the complexity of different tasks that we can leverage to improve our RAG setups. And I've bucketed these into different categories. So we have first beginner mode. Let's do pink. So we have beginner mode, we have adventure mode, and then we have nightmare mode. And each of these sit on a spectrum of complexity. So on one side, we can see there's less money, time, and complexity. And time specifically referring to latency. So how long does it take for your RAG system to respond to your users? And then how much money does it cost to build this out and also run it consistently based off of token usage? And then complexity is basically the build out itself. And on this side, we have more of all those things. Now, what I want to do here is I actually want to focus in on beginner mode, because this is really where the 80% of results come from. So we have these items here that give us a huge uplift in the RAG setups we have and the retrieval information we can get. I will go through these quickly to kind of give you an understanding of what they are, but note that we'll spend most of our time here. So if we go to the next one, adventure mode, we'll start with actually the second one because we're going to push re-ranking to adventure mode. I'm going to add this to the thing that we deep dive into because we can get a lot of results from a little bit of effort. So we're going to use that over here. Then we have, okay, so we have recursive, embedded, and small to big. I'm not going to spend a lot of time on any of these because we're going to spend most of our time, like I said, on beginner mode, but I'll quickly do a TLDR for each. So retrieval, recursive retrieval is simply put that we're going to have an LLM that's going to recursively look up context based off of the ask. And each lookup is going to be based on previous context. So what does that mean? So we have an ask that comes in. And our LLM is going to take this ask and they're going to pull some information to start with. So they're going to pull, say, information A. And then once we've got an A, we're actually then going to go for some more information based off of A and the ask. So we're then going to get B, and then we're going to keep going, and we're going to say, okay, we're going to get C, and we're going to base this off of B, A, and ask. And the recursive ask is we're recursively grabbing more context that's relevant based off the previous context. So that's kind of the concept of recursive retrieval. Okay, so we have that. Next, we'll work on embedded tables. So embedding tables is instead of just embedding text, because oftentimes with RAG, you're embedding massive PDFs and things like that, you're really looking at text mainly. But oftentimes in PDFs, there might be tables, there might be diagrams and other things. So embedded tables is if we're maybe embedding a CSV or an Excel file, we don't simply want to embed the text. We want to embed the relationships to the text between each other. So if we have a massive table here, there might be certain boxes, say this box is connected to this box. So when we embed this, we want to make sure that we embed not just the individual components, but also the relationship between the components. So that's kind of the embedding table piece. And then last, we have small to big. So small to big is basically we're starting with our ask again. We have our LLM. And then when we give our ask, the LLM is going to take a small bit of context. So we'll have make it a small box. So it pulls a small amount of context back. And then once it grabs this context, it sees, okay, there might be actually other context that's relevant to this small snippet that we want to expand out to. So we're going to take this smaller context as our starting seed, and then we're going to expand out even further. And then we're going to keep on expanding until we feel like we've gotten enough context to answer the ask in a comprehensive way. So we're expanding out over time to grab more and more context that's surrounding the initial context we received that's associated to the first ask. Cool. All right, so we have that bit. So we're going to go to nightmare mode now. So nightmare mode is where all the money, time, and complexity sits. And if possible, we should try to avoid doing anything that's too complex if we can get the answers back in a consistent way that we need for our use case. So try to just get it to the point where it's consistent, it's good enough, and then keep moving. But if you want to go to nightmare mode, some items here. So fine tuning, a lot of you already know what this is. So it's basically taking your LLM, training it on an additional data set to fine tune it for a very specific use case. Embedding fine tuning, slightly different. So we're actually fine tuning our embedders, where our embedders understand different terminology. So maybe we use an embedder that's used by everybody and it knows a lot of common language. But maybe you want an embedder that's very specific in, let's say, dermatology. So you have a lot of dermatology lingo, and you want that embedder to be very specific and understand what those terms mean, and also how those terms are related to other dermatology terms within the larger vocabulary of that specific profession. Then we have agent routing. So agent routing is when you have your ask again, you have your LLM, and then what we're going to do here is we actually have LLM1, and then we have LLM2. And the reason we have two here is because we're going to have a routing agent that's going to decide on which vector database to go to. So actually probably should do this. So we have kind of a branch here where we have different vector databases that hold different information. So we can say vector database one holds, say, animals, and then vector database 2 holds one on ice cream. And I can't write, so let's do ice cream. And then vector database 3 holds gymnastic moves. Gymnastics. Cool. And I'm not even sure if like moves is the right terminology. Anyways, so we have our LLM. We ask it a question. Based off the question that we ask it, when it hits this LLM, it's going to assess it and say, okay, which vector database most likely has the answer to this question? It's going to do that assessment. Once it's done the assessment, it's going to say, okay, well, this is talking about puppies, so it's likely going to go to the vector database for animals. So that's the premise of agent routing. Then next we have query planning. So query planning is when we're going to break down a query into segments. So when you have a question that comes in, say we have a question that comes in and it's something about pizza. So it says, let's say, what's the best Chicago style pizza in Chicago that's open late at night? Something like that. In that question, there's a few elements that we can break it out into. So we have our overarching question, but we can break that out into a few segments. So we can say, okay, what's the best pizza? We can say which one's actually not best. Let's location. So what are some places in Chicago that have pizza? And then of that, which ones have the best ratings? And then in addition to that, what are some ones that are open late? Because that was a part of our question. So we're going to take that question and we're going to break it out into 3 segments, and we're going to search on each one of those. So we're going to go to our vector database and we're going to search on each one of these bits, and then we're going to kind of aggregate all of that together. We're going to pull that back into our answer based off of the initial question. So we're breaking it out, consolidating it, getting our answers, and then returning it. And then last is multi-doc agents. So multi-doc agents it's a fancy way of saying multiple agents that look in multiple docs. So we have our question that comes in. We have multiple agents. So we say we have agent 1, agent 2, and agent 3. Say agent 1 looks at science books. Agent 2 looks at history books. And then agent 3 looks at, let's say, biology, which kind of is a subset of science. So we'll change science to art. Anyways, so we have these different things. When you ask your question, what's going to happen is if your question is quite comprehensive, so maybe it's something that goes across all of these, so art, history, and biology, all these agents can actually look up their segment of the question in their specialty, and they then can consolidate their answers back to then sending that back to you with a more comprehensive viewpoint of the kind of the cross points of all these different expertise or specialties. So that was a bit more than I expected to talk about on each one of these, but I hope that was useful for you to understand kind of what's the difference between adventure mode, nightmare mode, etc. But now we can dive into beginner mode. Like I said, we're going to pull in re-ranking here, and we're going to talk about each one of these one at a time. So first we have cleaning data. So this is probably one of the most important things we want to do to start out. And cleaning our data is important because it's the old adage of if you have garbage in, you get garbage out. And with cleaning data, oftentimes with PDFs, we have cover pages, we have different types of items inside of it. It's not necessarily text that matters to us. So there's a few things that we can do here for cleaning data. So first we can remove the junk. So that's going to be useless text, that's going to be ads, that's going to be additional headers, things that are relevant for our database. Then what we're going to do is we're actually going to fix some of the poorly formatted information. So if we have weird formats that come in our PDFs, we either want to remove it completely or reorganize it in a way that actually makes sense for us to retrieve that information later. And then lastly, we're going to handle broken text. Broken text could be, I'm sure if you've looked at any type of file through a computer, you can see that there's these ASCII languages and things like that. If there's weird symbols and things like that that aren't necessarily English and relevant for our questions, we're going to remove that as well. So we can either fix it or we can remove it like we've done up here. So that's cleaning data. An example of this really quickly, and we have our little pin that's in the way, so we're going to move our pin over here. We have a few things here. So first we have bad formatting. So this is bad, this is good. Bad, for instance, is when we have a massive header that has company report at the top. In this example, we're actually pulling in Tesla earnings, so Tesla related information. So we have a bunch of stuff here with a company report. We can see there's an advertisement. All of this is relevant, so we want to clean this out before we put it into our vector database. Better, a good example is when you just have the text that you need. So that's our example for cleaning data. Next, we have embedders. So we're going to put this over here. And for embedders, you can choose all different types of embedders. But really the basic point here is that you want to choose the most recent embedding models that are available that a lot of people are using and getting benefit from instead of using an old one. So the more modern and better you get, better and better. That's a weird one. So if you get an improved embedder, you're actually going to have better results. That's basically how it works. And currently at the moment, one of the best embedders that I've come across is I think it's OpenAI for sure, and I think it's their small V3. So if you just look it up, V3, I think small. They have a large one as well, but I'd recommend focusing on the small because it's a lot cheaper and gets similar results. Another thing you can do, depending on how serious your use case is if it's a quite serious use case, you need to ensure that you have the best embedder for your specific use case. You can test different types because some embedders are better at different types of topics. So if you have one embedder that's very good at science, one embeddor that's very good at history, we want to kind of test and compare those based off your use case. And now that we've gotten past this, examples. So a bad example is when you have an embedder and it only finds refund when it's searching the text refund. So that's almost like a regex, which is horrible. But if you have a good embedder, it's not just going to get refund, but it's also going to get associated words that sit in the same vector space. So it's going to get money back, it's going to get return, it's going to get refund as well, and all the other things. I'm sure there are tons of videos on YouTube that talk about vector spaces and how vector databases work. So I'm not going to necessarily go into detail here. But if you want to get a quick example, is when you have a word here, so say refund sits right here. Well, in this vector space, money back is probably here, return is here, and they're all kind of around refund. But iguana is probably going to be over here. So it's not going to be anywhere near close this vector embedding. So you can see this cluster here is what matters, and this is the type of kind of process of vector embeddings. You can actually see that I almost made a smiley face. Okay, next, chunking. So LLMs are somewhat like humans in a way, where if you chunk up data in a sporadic way, it's really hard for the LLM to understand what's going on. And that the same thing would happen to a human. So if you're reading an article and they just cut out chunks of the article and didn't explain what was in between, you would be lost. Same are LLMs. So you need to ensure that when you're chunking your information, you're chunking in a way that actually makes sense, and for the LLM to easily interpret the connections between chunks of text. And there are a few things we can do here for that. So one is the size of the chunk should be based off of meaning and not necessarily an abstract number. So if you have a bunch of text here and you're chunking it out, you want to ensure that when you slice off each one of these chunks, there's an understanding stop point. So either it's a period, it's the end of a paragraph, it's an end of a section, or something like that. There's an understandably good cutoff point to take it out, so you can then move on to the next piece. So having those good cutoff points is important. Another thing here is overlapping. So you want to ensure when you're kind of using this, you have overlapping points. So if I cut off the chunk here, the next chunk I actually want to cut off here. And the reason we're doing that is because this segment here is the overlapping point. So when the LLM pulls out those chunks, they can see there is a connection between the two. So we want to overlap chunks so they actually understand the cohesiveness between chunks. And I've seen percentages between 20 and 30% is a good rough number, a good estimate to start with. So you want at least 20 to 30% of the text between chunks to overlap. And then last is the chunk size. So we don't necessarily, like I said, stick to a certain chunk size. So sometimes you'll see like 1,000 chunk size or whatever else. You don't have to stick with that static number because if you come across a smaller section in a larger paragraph or a book, you can just take out that small section and use that. So instead of using the static 1,000 chunk, maybe you only need 500 for the smaller piece. So you want to adjust the chunk size based off of the size of the piece that you're pulling out that's kind of cohesive in that point. All right. So with that said, some examples. So a bad example is if you just basically cut off mid-sentence. Don't do that. A good example is when you cut out an entire piece where there's a good ending point and you can see that this is up to 15% last quarter and we have a period, so we stop there. So that remember, you just want to cut it in a way that it's not necessarily kind of convoluted and hard for the LLM to interpret. So next is metadata. So instead of strictly looking for information based off of vectors, so if we're looking for similarity between words, we can use that, sure, that's fine. But we also want to use metadata because we can actually utilize metadata in conjunction with vector databases and vector searches to improve our search drastically. And this is something I see a lot of people miss and kind of skip over. And this is kind of like old school database understanding. So we're going to take a chunk and we're going to do a few things. So if there are names, so there's different things we can pull out, all kinds of things. But one is like, okay, so maybe we want to add tags in our filters for names. Maybe we want to tag it by date. Maybe we want to tag it by location. Location. Maybe we want to tag it by, I don't know, animal type, depending on the item. There's all kinds of things we can filter by, and we can add these additional tags to our data sets before they're vectorized. So all this stuff can sit in our database, and our database is not going to only have this, but it's also going to have our vectors. And Supabase and others provide this capability. So we have this here, right? And then another thing we can do, which is quite interesting, is adding summaries. And we can summarize each chunk into one sentence summaries, giving more context to our LLM when they're doing the search in our database. So to do this, we would actually have an LLM at the front. So we have, say we have our data here, and we're going through the process of chunking this. And we actually have an LLM here that's taking each one of the chunks that have already been sliced up, and it's adding a one sentence summary to each piece. And it attaches that one sentence summary to that chunk in the filters in the metadata section. So when we do our searches in the future, we also have that additional smaller context to help our LLM understand which of these chunks are most relevant. So there's a million different ways you can use metadata and filtering, but it's really important that you use it. So an example here for metadata. So a bad example here is you actually have no metadata and you get random results based off of just the vectors. A good example is we have filters by date and topic. So we can see that the ask here, was show me Tesla earnings. So we can actually alter that and say, okay, instead of just show me Tesla earnings, I can pull that out and say, okay, we're looking at this quarter and we're looking at Tesla earnings as the topic. So we can take those out and put that into our vector database, and that's going to be one of the tags for our filters. All right, so next is tracking sources. So this is the old adage of trust but verify. So we should ensure that when we're getting information back from our RAG setups, preferably it tells you where the information came from. So you can then go to the location and say, okay, is it actually true? Did they actually get it from this location? And there's a lot of different ways we can do this. One of the simplest ways is just prompting the LLM to pull back the source as well. So when it brings you the information, have it have a brackets or kind of an emphasis. Maybe it's at the end of the sentence. It has brackets saying that the section that it came from. So it could be section 2. And if it's not brackets, then maybe it's something else where you include sourcing as well. This one's pretty simple. So we'll kind of move on to the example. So a bad example is it says that the warranty is last 5 years, but there's no source, so you don't know if it's true or false. Good example is it actually gives you, like I said in parentheses, this section and then the associated policy. So you can then say, okay, I'm going to go to section 2.1 and I'm going to see if that's actually true. All right, and then next we have good searches. So this one's pretty interesting, and I've applied it a few times and I've seen pretty good results. where you actually add an additional LLM in between to improve the ask from the user. So we have our ask here from our user, and then here we have LLM1, here we have LLM2, and then here we have our vector database. So say, just say V for vector database. And then when our ask comes in, this LLM here is actually going to rewrite the prompt. Because say the user sends a prompt in and it says, tell me about X, but it gives no specificity to X. Well, we can actually rewrite this with this LLM to add more keywords and more items to the prompt to make it easier for our next LLM to find the information. So once we've rewritten it, we can then send this to LLM2. LLM2 then can go to our vector database to get the information with the improved prompt that's been written by our previous LLM. So this is kind of improving the search. And then an example here for us is a bad question is tell me about Tesla earnings, too vague. But we can take this and we can rewrite it for a better answer or better question based off of context. So if somebody's asking me about Tesla earnings and it's in Q3 or right after Q3, it's in Q4, I likely know they're talking about Q3. So I'm going to guess and make an assumption that this is the type they're interested in. So I'm going to add that they're talking about Q3, they're talking about earnings, and then I want to add some more information about revenue numbers. So I'm improving their query based off another LLM before I get their information from a vector database. And then last, but certainly not least, is re-ranking. So when you get answers back from an LLM, you'll get multiple chunks. So you'll probably get, depending on the settings and the configuration you have, you could get between 10 to probably 25 to 50 chunks, depending on how you set it up. And when you get all these chunks back, all of these chunks aren't created equal, and they're all going to have ratings based off of their similarity to the question that was asked. And when you get these ratings back, you're not only going to check the ratings because you'll have the ratings. And like I said, these ratings are usually based off of similarity of words and how close they are to the word that was in the ask. But also, remember, we're going to have our metadata. Actually, we can just do this. We're going to have our metadata here. We're going to have that included as well with the filters. So we're going to take both of these, and this is going to give us some sort of score. A score of how good this item is. Usually it's going to be between 0 and 1. What we're going to do is we're going to re-rank this. We're going to re-rank it based off of the score. And after that, we're going to take maybe the top 5. So the rest we'll just chop off and not include. And we'll take those top 5, and that's the response we'll give back to our user. And that's going to help us give higher quality responses. So a bad example is we just give back the first result. So there's no re-ranking, we just give the stock price. A better example is we give back a higher quality response that's not strictly the first result, and it gives them the specificity of actually what matters to the question they asked. All right, Internet, I hope you found this useful, educational, insightful, all that stuff. And if you liked it, please like, subscribe, reshare with your friends, all that. And if you would like to work with me, I run a consultancy that helps companies automate their internal processes with AI. So if you're interested, link below. You can book a free 15-minute call with me, and we can discuss that later. With that being said, Internet, I appreciate the time, and I'll see you next time.